So this problem is different from a previous one where we had to find the Laplace of t to the power n when n is a natural number. Now we would like to look at the Laplace of square root of t, in other words, Laplace of t to the power 1/2. And instead of doing t to the power 1/2, let us look at Laplace of t to the power p, where p is any number. It doesn't have to be greater or equal than 0. So we can show, in fact, that we can go all the way to -1 without including -1. But 0 becomes an improper behavior. In other words, let's look at now first of all, what is the Laplace, the formula for Laplace. This is e minus st t to the power p dt. So you see, when p is negative, e minus st does not present any improper behavior at 0. But t to the power p, if p is negative, will present, or will introduce a vertical asymptote at 0. Therefore, we have an improper behavior at 0. And we can show that when p is greater, this is the p test, minus p is less than 1, which means that p is greater than -1, then the improper integral is convergent. But here, let's just focus on p greater than 0 anyway. So first, what we're going to do, we can show that this integral is convergent only when s is positive. Okay? Great. So here, I will not discuss the conversions. I'm just putting the answer here. That's part of the improper integrals behavior. Okay? So now we would like to find the formula for it. And what we do, we're going to do a substitution to take care of that. So we're going to put u equals st. Okay? So du is equal to s dt, or dt equals du over s. So the integral becomes Laplace of t to the power p is the integral from 0 to plus infinity, okay, e minus u over s to the power p du over s. And that's the integral from 0 to plus infinity e minus u to the power p du over s to the power p plus 1. So we can take the t to the power p equal 1 over s to the power p plus 1, the integral from 0 to plus infinity e minus u to the power p du. And as you can see, this term now is a number that has nothing to do with s. So keep in mind that if you look at now, we have to find in literature, I mean, this is known as what the gamma function that you can find everywhere, including I wrote a page on sosmath.com. So if you go to www.sosmath.com and you search for gamma function, you will find the page that I wrote on this function. So the gamma of x is equal the integral from 0 to plus infinity e minus t to the power x minus 1 dt. And we can show that this function, for the same reason I was discussing earlier, that 0, x minus 1 has to be less than 1, then it gives you, I'm sorry, because if you bring this one down, it becomes 1 over t to the power 1 minus x. So you want 1 minus x to be less than 1 to be convergent at 0. And this will imply that x is positive. So it's convergent when x is positive. That's the domain of the gamma function. Okay? So here, some of the properties, I mean, we can find them. So first of all, gamma of x plus 1, by integration by parts, we can show that this is x gamma of x, number 1. And gamma of 1 is equal to 1, because this will give you 1 minus 1, 0. T to the power 0 is 1. So we have the integral from 0 to plus infinity, e minus t dt, and that's very easy to do. So gamma of 1 equal 1 is very, very easy. So now from here, we get that gamma of 2 is 1 gamma of 1, which is 1, times 1. Gamma of 3 is equal to 2 gamma of 1, which is 2. And it's very easy to see that gamma of n is n minus 1 factorial. Or if you want, gamma of n plus 1 is n factorial. So this function gamma is seen as an extension of the factorial function. That's if you take the factorial function defined on the natural numbers and you want to extend it to the real numbers. So the gamma function is a wonderful tool. In any case, so here, what was Laplace again of t to the power p? It was capital gamma of p plus 1 over, was it p plus 1 or p? Yeah, over s to the power p plus 1. So in particular, if we take t to the power n, this is n factorial s of n plus 1, and that's one of the formulas we found before. So here we wanted to find square root of t, and that's gamma of 1 half plus 1 over s to the power 1 half plus 1. In other words, gamma of 1 half plus 1 over s to the power 3 half. So this tells us, using the other formula I gave you, okay, so this is 1 half, in other words, x gamma of x of 1 half. And gamma of 1 half, okay, is square root of pi. Okay, there are many ways. Either use the, I have it on the website on SMS Math, you can use the beta function, or you can also use the integral of e minus x squared from 0 to plus infinity. Anyway, so there are many ways we can prove this formula, and therefore gamma of 1 half plus 1, that is square root of pi over 2, which tells us that the Laplace of square root of it is square root of pi over 2s to the 3 half.